Hello everyone and welcome to day 7. Today we're going to continue on the idea of what a sine and cosine curve is and how it relates to an issue, of course the Ferris wheel, but maybe even other things too. So let's look at how this idea, and we talked about it a little bit before, but how this idea of if the period changes, what happens to the Ferris wheel. And so let's look at A. So what we're going to do is we're going to look at A today and maybe another one, and then I'm going to have you guys try the two that we don't do on our own for class. So one, we're going to find the height, we're going to find the amplitude, explain what that means, find the period, and then find the angular velocity. So let's look at A. We have 15 sine of 0.5 t plus 17. So let's look at the two things that you should be able to pick up immediately. The 17, this is the y displacement. Again, it's the position of the midline. So what we know is that the midline is shifted up 17 meters. 15 is the amplitude, or the radius of the circle. The radius of the circle being, so we have this circle right here. So this is for A. And we know that the radius is 15. We also know that this midline, I don't know why it goes away, this midline is at 17. Meaning, where is the bottom of this circle? Well, if the radius is 15, we know that we're at 2 here. This is 17, and this is 2. We know our highest point is 15 plus 17, which equals 32. So we've got that. So the height, find the height of the seat when the motion begins. Well, let's say here if we plug in 0, we know that sine starts at the midline, so 17 meters. Find the amplitude. Well, we already did that. The amplitude is 15, and it's 15 meters. And what does that mean? Is that we know that the Ferris wheel will go up 15 meters from the midline and also down 15 meters from the midline. So we know that our minimum equals 2 and our max equals 17 meters. Should label here. And find the period. So this is a little bit of the difficult part. This 0.5, if we think back to transformations, is on the inside. There's really parentheses around there. So 15 means it was stretched. Okay? The 0.5 is on the inside, so we're going to be talking about horizontal. And if it's opposite of what we think, we really realize that this was stretched by 2. So if we were to graph this, we would have an xy axis. We would have our midline being at 17. And this is not going to be straight at all. And if we graph it, we realize that we start at the midline, because it's a sine curve. We go up to 32. We go back down. We go down to 2 and back up. We realize that that maximum is 32. The bottom is 2. It does not hit the actual x-axis. And so, if it was stretched, we talked about this last class, this usually would be 2 pi, right? If I write this down, and it's not really, it's really 2 pi, which we talked about was around 6.28 minutes, 28 minutes. But we're stretched now. So instead of being 2 pi, if it's stretched by 2, what are we really at? We're at 4 pi. And so find the period. The period for A is 2 times 2 pi, because it was a vertical stretch of, or a horizontal stretch of 2, which is 4 pi. And so this would take approximately 12.56 minutes. It's not seconds, just remember that. Minutes to complete. And now we're going to talk about angular. So remember that angular velocity is the idea of revolutions per minute. So we have 1 revolution per the 12.56 minutes. And that's your actual angular velocity. If we wanted to do that out, get your calculator. you're going to approximately 0. Get it right here. 0.0796 revolutions per minute. Again, that's extremely slow. Why is that slower? Because we stretched it out much slower than what we had before. So that was all for A. If we look at C here, and I know it took a little bit, so if we look at C, I'm going to go over it a little quicker, and then you guys are going to do B and D on your own. If we look at C, I'm going to do C in black over here. If we do the first one, what's the height when the motion begins? Notice we're at 13. We went up 13. We start at the midline, so we're at 13 meters. What is the amplitude? 12 is the amplitude, so 12 meters. What does that mean? We know that our max is going to be 25, and our min is going to be 1. How did I get that? 12 plus 13, and 13 minus 12. Find the period. Now this is the tough part. This is a a horizontal shrink. This is really by 3/2. So if I'm shrinking, I got to multiply by the reciprocal. So we know our regular period is 2 pi. I'm going to actually multiply by 2/3 here. And we're going to get 4 pi over 3. That is a shrink. Notice that's 1.3333. It is smaller than 2. 2 is larger than 1.33. So we have 4 pi over 3. If we multiply that with that pi in there, you're going to get approximately, again, these are all approximate because there's pi in there, 4.2 minutes for 1 revolution. Again, let me just talk about why we multiplied by the reciprocal. It's opposite. The opposite of a fraction is the reciprocal of it. Okay? It's just like we're dividing instead of multiplying. So we had to multiply by the reciprocal. And the angular velocity, again, is 1 revolution over approximately the 4.2 minutes. Okay? And you should be able to get that in your calculator. Hint, when you go to do B and D, you're at cosine. Remember that you're starting at the top. So please make sure of that. So pause it and try B and D, please. Pausing it. So please take a second, now that you've completed B and D, and turn to page 32. We'll finish the other stuff in class, the other problems. I want you to turn to page 32 because this is answering the next question in the packet. So we'll just answer it here in the summary page. So page 32. 1. How can the values of a, b, and c in these two trig functions be used to find the following? So look at a, b, and c. Notice that they're in the same position for both sine and cosine. The amplitude of the function. So let's talk about it. How do you see it? Well, it's just the a value. So the amplitude is the a value. The period. Now be careful here. Remember that the period, if this is 1, if the b value is 1, if I had 5 sine of t plus 3, the period is 2 pi. You know that. There is no horizontal shift either way. So the period of the function is 2 pi divided by, well, in this case, if it's still 2 pi when there's a 1, it's divided by your b value. Reason being, if it had been 2, we know it's a horizontal shrink of 2. Look at what happens here. 2 pi divided by 2 equals pi. It was shrunk by a half, and if it was originally 2 pi, you're dividing by it. So this is how you find the period. 2 pi divided by b. The frequency is just the b value. The frequency is how many cycles in 2 pi. So just think of that. Think of this. There's 1 cycle in 2 pi because the b value is 1. It's how many times did it complete 1 full cycle. The y displacement, you know this, is the c value. We've done this enough. And the equation of the midline is the y equals c. What are period and the frequency of a periodic function, and how are they related? Again, we just went over, I just talked about that. The period is how long it takes to complete one full cycle. And the frequency is how many cycles in 2 pi. So, what is the amplitude, period, and frequency of sine of t? We've talked about this many times. There is no transformations here in either 3 or 4. So the amplitude is 1, the period is 2 pi, and the frequency is 1. Amplitude is the radius. There was no vertical stretch. The period, how long it takes, 2 pi radians, and the frequency, 1. And the same thing for cosine. Gets a little more difficult right here. What's the amplitude, period, and frequency of this function? Notice the negative only is a reflection over x-axis. It does not change the amplitude, period. Okay, it only changes the midline because it was reflected over it. Okay, so let's look at this. The amplitude is 3. No negative 3, just 3. It is the distance. Distance cannot be negative. Period. Now this is the more difficult part. It's 2 pi divided by your b value, which is 2 pi over 5. Now we just talked about this in the one before that. That equals, since you're dividing, you multiply by the reciprocal, 5 over 2 pi. Those 2 pi's actually will cancel because you're multiplying and you're left with 5. Your period is 5, meaning that it takes 5, whatever it is, units to complete one full cycle. Let's skip frequency for right now. Our vertical shift, okay, is down 7. Now I was incorrect in what I said before. The reflection actually does not change the midline. The midline is y equals negative 7. Okay. So what happened here, I feel inclined to show you now that I told you wrong. If the negative had not been there, okay, we would have had a midline. We had a midline of negative 7, and our min and max would be negative 10 and negative 4. All of this did, it usually would have looked like this. What happens instead is now it's reflected, and so now it looks like this. Why, you may ask? The reflection occurs first, and then the transformation is shifted down. So we really were starting here, okay, and then shifted all the way down. Notice that your period, how long did it take to go from here to here? The answer is 5, actually, because our period was 5. Started at 0 and went all the way to 5. The middle is 2.5. Okay? So, quick thing on how to do amplitude, period, and frequency, or vertical shift and equation of the midline. We'll keep doing more of that next class. What I would like you to do to finish off the notes is finish this page on 33, is match the graphs, please. And not all of them will match. And with that, I hope this lesson went well for you, and I will see you in class to answer any clarifying questions and to finish the rest of the notes, the 2 problems on Alaska and the pendulum swinging. Enjoy the day.